So in this clip, we're going to be looking at the nitration of benzene now, right? So let me just have it here, the nitration of benzene, all right? So the nitration of benzene. So the first step the reaction that we're looking at specifically, let me just write down the reaction, right? We're going to have benzene. We're going to react it with nitric acid, right? So we're going to have the acid here. It's going to be in the presence of H2SO4, right, as an acid substituent under 55 degrees Celsius to give us what we know as nitrobenzene, right, NO2, right, plus some water. Okay, so that's what we have there. So let's have a look at the mechanism now. The first step 1, is always the creation of your electrophile. So we're gonna have the creation of the electrophile. And in this case, it's a nitronium ion. All right. So it is our N. I think the nitronium ion looks somewhat like this. All right. So it looks a bit different. I think it's hyperconjugated in some type of way. All right. But the nitronium ion NO2. All right. So it's gonna be NO2 plus. That's the nitronium ion that we're looking at. All right. So let's have a look at this now. All right, we're gonna have the creation of that. So we know that we're reacting with HNO3 plus H2SO4. All right, so this reaction, what this will give us is H2NO3 plus, all right, and we notice that all that happening is that a hydrogen is moving from the sulfuric acid to create hydrogen sulfate, and then that adds the extra hydrogen onto the acid there. All right, so we have this reaction happening first. All right, now we're going to be taking our H2NO3 plus, right, and that will now decompose to give us the nitronium ion in solution plus some water. Right, so this is the water that we see being produced as a byproduct in the overall equation there, right? This is the water that we see. Okay, so let's have a look now. We're going to be using the nitronium ion now to add to the ring. So step 2 rather, the electrophilic, let me just put E plus addition, right? Electrophilic addition. No. So we're gonna have the benzene ring. It's similar to the halogenation of benzene. We're gonna have the benzene ring like this, right? No, we don't need a Friedel-Crafts catalyst or anything like that because the nitronium ion is already a strong electrophile, so you don't have to worry about that. So we're gonna have the donation of the pair like that. Right, this will produce unstable intermediates, right? So NO2, and we're gonna have our H right here like this. So hopefully everybody can see that. Let me just add in back my bonds. All right, hopefully everybody can see that. All right, so this is what's happening here. And then in step 3 now we have deprotonation. Deprotonation, right? So in this step now we're gonna take our intermediate and we're gonna now realize the fact that because the aromaticity has been broken, right, we're gonna need to restore sp2 hybridization on this carbon. So the electrons from the hydrogen are going to be moving back into the ring system to restore stability, and then we're going to have that removing as a proton. So what is the result of this? The result of this is going to be nitrobenzene, NO2, right? Nitrobenzene plus a proton. This proton now will actually be added back to our sulfate, right, to create, or to recreate rather, our catalyst. Remember, catalysts are chemically unchanged at the end of reaction. So H2SO4 is recreated. Okay, so that is what's happening. So in step 1, we have the creation of our nitronium ion. We show the creation of that. Step 2, we have the electrophilic addition, right, showing the creation of the unstable intermediate. And in step 3, we have the deprotonation, right, resulting in nitrobenzene and the restoration of our catalyst here, H2SO4. Okay, and remember the conditions, right? In the acidic environment at 55 degrees Celsius, so it must be a bit cold. Okay, so that is that.